So I1 is 2.5 amps, as given over here. So 2.5 amps times by R1 was 1 ohms. That was given to us. So V1 is 2.5 volts. And you can do the same thing for V2. V2 is I2 times by R2. And I2 was 2.5 amps. So it's 2.5 amps times by resistance 2 was 1 ohms. So it's 2.5 E. Which we could have got since the resistance is the same. So between resistance 1 and resistance 2. So we could have just split the 5-volt equally between resistance 1 and 2. And you have 5-volt going through that path, so we could have done that. But we could also calculate it out this way. All right, so now let's figure out what is the R3456. We already figured out what it was. R3456 resistance was here. We figured that out right here. So since we know R3456 is equal to 1.33 ohms, we also know the voltage that's gonna go for 3456 is 5 volts because V total is 5 volts and is feeding the entire parallel circuit here. And in parallel circuit, voltage doesn't drop, so V3456 will be 5 volts. So that means the voltage for that entire area will be 5 volts. So then current of 3456 is equal to V3456 all over R3456. So then I3456 is equal to V3456, which is 5 volts. R3456 is 1.33 ohms. So I3456 is equal to 5 divided by 1.33. 3.76. And so what that means is this entire area is going to have 3.76 worth of current going through. So 3.66 amps will be split among here, here, and here. And then they're all going to reconverge over here. And this guy will also have 3.66 amps. So I3 will be 3.66. And so R3 is 1 ohms. The current of I3, so I3456 is equal to I3. And also is equal to I4, also equal to I3456. So also equal to I456. All right, so how do we figure this R3? How do we figure out the V3 then? So V3 is equal to I3 times R3. And I3 is 3.66 amps times by R3 was 1 ohms. So V3 is equal to 3.66 volts. Okay. And now that you had 5 volts going in here at the beginning of the circuit, but now R3 is using up 3.66 volts. So that means the remaining R456 is using 5 volts minus 3.66 volts, which is 1.34 volts. So R456 is using 1.34 volts, And since it's a parallel circuit, it's actually using it's actually using 1.34 volts here, 1.34 volts here, and 1.34 volts here. Because they're parallel, if you start with 1.34 volts, then this entire region will be using 1.34 volts. And since it's a parallel, they have the equal amounts of volts, and they don't get diluted. So now you can figure out the I4, which is equal to, that's V4. This is a V5. This is the V6. So I4 is equal to, so I4 is equal to V4 over R4. So V4 is 1.34 volts, and R4 was 1 ohms. So therefore, I4 is 1.34 amps. Okay, and I5 and I6, they'll be the same because they all have the same resistance. So it's gonna be exactly the same as the I4. So I can write it down here. So if you have I5 is equal to V5 over R5. V5 is 1.34 volt. R5 is 1 ohms. So again, this will get 1.34 amps. Okay, and then the I6 will be exactly the same. Is I6 is equal to V6 over R6, which is equal to 1.34 volts over 1 ohms. So therefore you get 1.34 amps. All right. Hopefully this question, all these calculations have helped you to see how to calculate these. And hopefully things will get more clear as you practice. All right. We'll meet again for next examples.